Okay, you guys, so we're going to get ready to talk about what I know, or what you probably know as function notation. To prepare that, what I'd like to do is explain why we have the notation, and then obviously in that explanation, hopefully we'll see how we use the notation. But here, what I'm basically showing you is kind of our old way of doing things, right? What we usually have is an equation that that relates y to x. So y being my dependent variable depends on x this way. It's a line, right? Half of x plus 3. In the next relationship or function, if you would, right, y, right, depends on x. You square it and you add 4. So independent variable, and this is how the dependent variable depends on that independent. Here, the dependent variable y depends on x in an absolute value statement. And then here, right, our dependent variable depends on x in a rational expression. So we have 4 different relationships, all right? And in the real world, this also happens. I mean, just simply thinking business-wise, right, there's many things I talk about functionally business, right? There's the cost of my business, there's the revenue of my business, there's the profit of my business, right? There's the health care of my business, right? There's on and on and on. So there's just 4 different functions that are related to my business somehow. And so rather than going through and calling everybody y, we've created function notation. And here's why, right? If I asked you guys to find y when x equals 2, right, what would you have to do to guarantee you got the right answer? All right? What would you have to do if I put this on a test, right, gave you 4 different relationships between y and x, and then asked you to find y when x is equal to 2, right? So on a test, you would have to literally, right, just to make sure, you'd have to plug the 2 here and get a y value for the line, right? Plug it here, get a y value for the parabola. Plug it in here and get a y value for the absolute value. Plug it in here and get a y value for that. Same thing if I reverse that, right? Find x when y equals 1. Again, without knowing which relationship I want, you just to guarantee you got it right, you plug 1 to here and solve the equation, put 1 here and solve the equation, put 1 here and 1 there and solve the equation, right? So, and again, we don't really know which one, right? You're just making sure you're putting it on all 4. Sounds redundant, sounds ridiculous, and that's the case. And that is why we have function notation. So for starters, right, let me go ahead. All we're basically doing is we're replacing the y with something that looks like that, all right? And we read this as f of x. And so that's the first thing you're going to have to get used to, is we're no longer calling y y. It's now this notation f of x. The f is basically the name of the function, right? And then this part's telling us is what the function depends on. So, all right, that's basically what that is. So what I can now do, right, here's the new way of doing things, is rather than calling the first relationship y, maybe I call that f of x equals 1/2 x plus 3. Since I can give it a function name, right, perhaps rather than calling this y equals x squared, I call that g of x equals x squared plus 4. So I've already distinguished between these 2 functions. This is the function named f, and this is the function named g, and they both depend on x, just like they originally did anyway, so that's not changing at all. Maybe the next function, rather than calling it y, right, I call it h of x, right? So now I've distinguished between 3 functions by using my new notation, and perhaps I call the next one r of x, right, just to distinguish it from the others. So now what I've done is I still have the same relationships I had before, but the function name is telling me 2 things. Number 1, I'm dealing with a function. I have a one thing in, one thing out. You give me an x, I'll create one y. You give me an x, I'll create one y. You give me an x, I'll create one y. So we don't even have to test whether these are functional or not. Up here we would still have to make that test. So there's one payoff by using the notation. I know I'm dealing with a function. Second thing is this type of question is no longer going to be ambiguous, right? I'll ask you to find g of 2, right? And the notation I'm telling you, right, is you're going to go to the g function, right? So this guy right here, and what I want to put into it, right, the input, the x value, is equal to 2. So rather than saying all this and being ambiguous and trying to figure it out, I'll just tell you straight out, find g of 2. And that pretty much tells us what we need to know. So finding g of 2, I plug it in, right, do my work, and we get 8. So g of 2 is equal to 8. Or in ordered pairwise, right, that's basically saying that we have the ordered pair 2, 8 on that graph. So if x is 2, the output for the function g is going to be 8. So that's how we basically use that function notation. So I don't have to go waste time finding the value of y when x equals 2 for the other 3. I'll just do what I want. Same thing here. Rather than saying find x when y is 1, I'll basically say find f of x equals 1. Right? And now what that does, it tells us, okay, well, which function are we working with? We're working with that function right there. Right? And again, I'm basically telling you in a functional way that y is equal to 1. So I'll come to this function, I'll replace that with 1, and now I can do the math, right? In this case, subtract 3 from both sides, we get negative 2 equals 1/2 x, multiply both sides by 2, and we basically get that x equals negative 4. So functionally, we're saying that if you put a negative 4 into the function f, the output's 1. Or ordered pairwise, what we're saying is that negative 4 as x creates an output of 1. Of course, that's easy to check too, right? Half of negative 4 is negative 2, plus 3 gives us 1. So we have a more concise way now, right, of saying pretty much the same thing. So we use a function name to distinguish the function. That basically tells us, especially when I have more than one function to deal with, the notation tells me exactly which function to either let x equal to or to let y equal to and do the rest. Back to the function name as well, maybe we're talking about a population over time. So again, that's a nice way to, P stands for population and T represents time. So I have some function, right? The independent variable is T, right? And the P, right, is what is the dependent variable. It depends on t in some way, and so maybe it's maybe it's a linear relationship, right? Maybe it's 1/4 t plus 50, all right, or whatever the case might be. Maybe we're talking about the amount of money in my bank account, right? So A is for the amount, and my amount depends on the time of the month, right? And so there's some other function there. So that's another nice feature about our function notation, is I can actually use some names that are more meaningful to me. Cost function, right? Maybe I call that C of x, right? So x is the number of units, and I'm going to find out how much they cost, right? Revenue function, right? X is the number of units my company produces, and R is the revenue we produce. All right, so my revenue depends on the units I produce. My cost depends on the number of units I produce. My profit function, maybe we call that P of x. Right? My health function, maybe I call that h of x. So now we have a function name to distinguish one functional relationship from another, and then I can use my function notation to do that. Truly, the last thing I'll mention is notice the difference between when I let x equal a number or when I let y, right? Inside the parentheses, that's the dependent variable. So if I want to let x equal a number, functionally it looks like that. If I want to let y equal a number, then functionally it looks like this. So here we got to find y, and here we got to find x, given y and given x respectively. Obviously we need to practice this. Some of you probably are used to it, but maybe hopefully you have a little bit deeper understanding of what the heck's going on, because it is different. Very different notation, but very, very useful. And we're probably going to be using it for the whole rest of the semester. So make that change. We're no longer calling y y. We're giving it a function of x name, function f of x name, g of x name, h of x name, and r of x name, and anything of x name, right? And then we can even be, more a of t, p of t, c of u, right? All kinds of stuff. All right, so more practice coming soon now that we've introduced ourselves to the function notation. Let's go use it.